everyone, welcome back to my channel. Today we are doing differentiation worksheet. It's not the entire differentiation, it's only on the basic rules, how to differentiate any algebraic equation, and as well as the tangents and normal. So this is the sheet on it, and that we will be doing. Also, if you have any doubt, you can comment in the comment section. I'll definitely answer it, or if I feel, I'll make a video on it as well. Okay, so the first question says find dy over dx. That means we have to find the derivative of y is equals to 8x cubed over 3. With the help of a first principle, we have derived that for x to the power of n, differentiation is nx to the power of n minus 1. So same we'll be doing, and also if we have any constant before it, it will remain as it is. That means 8 over 3 is a constant, and we have to differentiate x cubed with respect to x. Using the same formula, we can clearly see n is 3. So that means for x equals 3, this will be, I need to replace n with 3. That will give me 3x, 3 minus 1, which is 3x squared. That is a over 3 times 3x squared will give me 24x squared, and that's the answer. Next is also the algebraic one, and we can simplify it before we differentiate it. So that will be, if I cancel this one, this will become half. And using the laws of indices, I'll get to know that if I'm dividing two exponents having the same base number, we have to subtract the powers. So it will be x to the power of 9 minus 4. So it will become x to the power of 5 over 2. I can take out half as common and need to differentiate x to the power of 5 using the same formula. I'll get x to the power as 5x to the power of 4. So final answer will be 5 over 2 x to the power of 4. Part C, again we have to do the same thing. That means let me simplify it at the beginning. I can take out x squared as common from the numerator, though I can take x cubed, but denominator has x squared and I'm taking out as common so that I can cancel it out. So this will become x plus 4x squared over x squared. This will get cancelled out. Remaining is x plus 4x squared. I have already explained that in my theory, and if you're not aware of, I am pasting the link in the description box. You can go through it. You will access the video where I have explained how to differentiate the algebraic functions and tangent and normal, how to find the equations and gradients. So in that I have explained that if we have terms separated by the positive or negative sign, 2 terms, 3 terms, we can differentiate them separately. So I am differentiating x separately and taking 4 out as common, or because it's a constant, differentiating x squared. This will be 1 and this will be 8x, because differentiation of x squared is 2x and multiplied by 4, that will give me 8x. Now moving on to the next one. Find the gradient of the curve with equation y is equals to 4 root x plus x squared, x to the power of negative 2 over x squared at the point where x equals 0. That means it says that this is the equation of, let's say this is the curve, and we have to find the gradient at x equals 1 like this. Here we have to calculate gradient. So obviously, how you calculate gradient? By finding the derivative. So I need to differentiate this one. Let me simplify it. So this can be 4x and root is half over x squared plus x to the power of minus 2 over x squared. Same using the laws of indices. This will become 4x to the power of half minus 2 plus x negative 2 negative 2. Whenever we divide, obviously the powers get subtracted. So this will be 4x to the power of minus 3 over 2 plus x to the power of minus 4. Now we have to differentiate it. So that will give me 4 times minus 3 over 2. See, same, I'm applying the same formula. That is x to the power of n becomes nx to the power of n minus 1. That means nx to the power of n minus 1, which will give me minus 3 over 2 x to the power of 5 over 2. So x to the power of negative 5 over 2 plus minus 4 x to the power of minus 4 minus 1 will give me minus 5. On simplifying, I'll get minus 6 x to the power of minus 5 over 2 minus 4 x to the power of negative 5. We can take out common as well, or we can further try to do the simplification, or this is the most simplified, we can just leave right there as well. Question number 3 says a curve has, it says at point x equals 1. That means once we have found the derivative, we have to substitute the value of x as 1. So dy over dx we have calculated as minus 6 x to the power of minus 5 over 2 minus 4 x to the power of minus 5. All we need to do is just substitute 1, and 1 to the power of anything, like any finite number, is always 1. So this will give me minus 6 minus 4, which is minus 10. So minus 10 is your answer. Moving on to the question number 3. A curve has equation f of x equals x cubed minus 4x squared, and we have to find the gradient of this curve at x equals negative 4. Same, we have to differentiate it. So differentiation of x cubed, because these are two terms, so we can differentiate them separately. Differentiation of x cubed is 3x squared, and differentiation of minus 4x is minus 8x. Again, I'm saying I'm using the same formula. If you have a constant, keep it as it is, and after differentiation multiply it with, say for example, this is 4 outside, so that's why I have kept it as it is, and after differentiating x squared, I'll multiply my differentiated function with it. So the differentiation of x squared is 2x, and 4 is already outside there, so that will become minus 8x. This is the differentiation. Now we have to put x equals negative 4. That means after differentiating, we have to put x equals 4. 3 and 4 squared minus 8 times 4. So in place of x, I have substituted 4. So that will give me 48, and this will give me 32, and my final answer is 16. Now part B says find the coordinate of the point on the graph y equals fx where the gradient is negative 5. In my previous video, I have already explained that the function that I'm getting after differentiation is the gradient function, and by substituting the different values of x, we'll get the different values of gradient at different points. So here they are asking you that at what point or points you'll get the gradient as negative 5. So our gradient function is 3x squared minus 8x is equals to minus 5. So I need to bring it here. It's 3x squared minus 8x plus 5 equals 0. Okay, now we can easily factorize this one. The product is 15, a times c, and where sum is minus 8, so two numbers are negative 5 and negative 3. So negative 3x squared minus 3x minus 5x plus 5. 3x out is common, x minus 1, minus 5 is common, x minus 1. So two factors are 3x minus 5 times x minus 1, and that will give me two different values. X1 is 1 and x2 as 5 over 3. So these are the points basically on this graph where the gradient is negative 5. Part C says find the intersecting points of the given curve and the straight line y equals negative 3x. So our curve is x cubed minus 4x squared. So x cubed minus 4x squared is our one curve, and this is the another one, and wherever one curve or straight line or two straight lines, two curves, they meet, they intersect, that means they are sharing the same values of x and y. So that means this is a simultaneous equation that we have to solve, because simultaneous equations are the set of equations where they share the same values of x and y, or the different variables. So I can equate x cubed minus 4x squared, because in both the cases y is same, so I can equate them. This equals negative 3x. X cubed minus 4x squared plus 3x, I have brought 3x, negative 3x onto the left hand side. I can take out x as common. It's x squared minus 4x plus 3. Now x squared minus 4x plus 3 is a quadratic expression, and we can factorize it further. Product is 3 and sum is negative 4. That means negative 3 and negative 1 are the numbers. So x times x minus 3 times x minus 1 equals 0, and this will give me 3 intersection points. x1 is 0, because this is also one of the factor. Don't just miss out. Don't just divide x both the side and forget about the x. No, it is one of the factors, so you have to equate that to 0 as well. x2, by equating x minus 3 to 0, will get 3, and x3 will give me 1. So there are 3 intersection points. So x equals 0, 1 and 3. Now it says point, that means obviously we have to give the values of y as well. So for the first point, x is 0, and sub in the value in any of the equation. This one is much more simpler, so I'm substituting here. That will give me y is 0 as well. So first intersection point. Second intersection point, when I substitute x equals 3 or 1 in increasing order, that would be 1. So on substituting 1, I'll get y as negative 3. So 1 comma negative 3, and c is 3. So on substituting, I'll get negative 9. So these are basically 3 intersecting points. Part D said find the gradients of all the points of intersection. So we already have this gradient function, which is 3x squared minus 8x. So 3x squared minus 8x. And we have to calculate gradient at all these points. That means dy over dx at x equals 0 will give me 0. So at x equals 0, the gradient is 0. Next is the gradient at x equals 1 will give me 3 minus 8, which is negative 5. And finally, the gradient at x is equals to 3. That will give me 9, 27 minus 24, which is 3. So that's it. Question number 4 says, again, we have to differentiate these functions. So root x is x to the power of 1 over 3. And 3 over root x, and if I bring it onto the numerator, will become x to the power of negative half. Sorry, 1 over 2. So this will become half x to the power of half and minus 1, that will be negative half, plus 3 and times negative half x to the power of negative 3 over 2. I'm just applying the same formula. Answer will be, finally, if I'll simplify this, or if I keep it in a fractional form rather than converting into a third one. So we can write x to the power of half minus 3 over 2 x to the power of 3 over 2, and that's the final answer. Moving on to part B, again it involves the fractional indices, plus 2 half and x to the power of negative 2. This will be minus 3 over 2 x to the power of negative half minus 2 over 2 x to the power of minus 3. Further, we can simplify minus 3 over 2 x to the power of half minus 1 over x cubed. Question number 5. F of x, a root x plus b, and f dash x, this is f dash x, and this is f double dash x. So f dash x, that means dy over dx. We are differentiating our function one time. And f double dash x, that means we are differentiating our function two times. So our f of x is a x to the power of half plus b. Let me differentiate it one time. Will give me a over 2 x to the power of negative half plus b. And it says f4 is f dash 4 is 9 over 4. That means when I'll differentiate this one and substitute x equals 4, my answer will be 9 over 4. That means f dash x is 9 over 4. So f dash 4 means I need to replace x with 4 plus b. So here it was 9 over 4, and this will be, if I bring it in denominator, that will become a over 4 plus b. This is a and this is 9. So multiplying 4 both the sides will give me 9 is equals to a plus 4b. That's my first equation. Second equation in terms of a and b will get when I'll differentiate it second time. Now differentiate this one. If you will differentiate it again, you will get second derivative. So f double dash x is equals to, I'm differentiating this one now, will give me minus a over 4 x to the power of minus 3 by 2, and derivative or differentiation of a constant is always 0. Substitute 4 here. So minus 9 by 4 times x to the power, which is 4. F double dash 4. 4 to the power of 3 over 2. That will give me 8. So f double dash 4 is already given as 63 by 32. So substituting, I'm just writing it here, 63 by 32, and here I'm substituting 4, which I have already done, but I'm writing it as it is, 9 over 4. 4 to the power of 3 over 2 is 8. So 63 over 32 equals minus 9 over 8 times 4 is 32. Cancel this out, and sorry, this is not 9, it's 8. From here I'll get a as negative 63. So substitute a as negative 63 here. A 9 is equals to negative 63 plus 4b. Bring it here. That will give me 72 is equals to 4b, and b is equals to 18. So hence we found the value of a and b. A is negative 63 and b is 18. Question number 6 says f of x is equals to x cubed minus 4x squared plus 5. The tangent at point x is equals to 1 meets the x-axis at point A and y-axis at point B. If O is the origin, find the area of this triangle. So see, it says this is x-axis and y-axis and x-axis, and we have this curve. Let's say it looks like this, something like this, say for example. Now we have a tangent at point x equals 1. Let's say this is the point at x equals 1, something like this, something like this. Not exactly like this. Yes. So this tangent meets x-axis here at point A and here at point B, and this is O, that is origin, and here obviously this is not, because this is a tangent at one point, this is cutting at another point. So let's say this curve looks like this, say for example. It's like this, something like this. Say for example, I'm just drawing it randomly. To make you understand that exactly they are saying that this tangent, this is at x equals 1, and this tangent is meeting. That means if I want to know the intersecting points of this tangent and the x-axis and y-axis, we have to calculate the equation of tangent. We know equation of tangent is y is equals to mx plus c. So for that, we should know the point at which tangent is. So x we know is 1, and y how can we calculate? Putting 1 here. So that will give me 1 minus 4 plus 5, which is 2. So y is 2. So this point is actually 1 comma 2. So for y is equals to mx plus c, we have the point. Now we have to calculate gradient, and obviously gradient at this point, or the gradient of the tangent at this point, is the function, the gradient function. Obviously, I have explained you when I was explaining you the theory that at a given point, if we want to calculate the gradient, it's the way calculus tells us to find the derivative. So, geometrically, if I want to calculate the gradient at a particular point on a curve, I have to draw a tangent and find its gradient. That means gradient at this point, this tangent is same. So we have to find the derivative function of, or the gradient function of this. That will give me 3x squared minus 8x plus, and just 8x, because the differentiation of a constant is 0. And at x equals 1, that means 3 minus 8 minus 5. So now we have the gradient of this tangent, which is y equals minus 5x plus c, and the point is 1 comma 2, so 2 and minus 5 plus c. So from here c is 7, so my final equation is y is equals to 7x plus, y is equals to, gradient is negative 5, so negative 5x plus 7. This is our final equation. That is, the equation of this tangent is y equals negative 5x plus 7. To find the y-intercept, obviously x is 0 at this point. So making x equal 0, I'll get y as 7. That means this point is 0, 7. And to calculate x-intercept, I have to make y 0. That will make x as 7 over 5. That means this point is 7 over 5, 0. So this length is clearly 7, 5. And this length is clearly 7. And this is a right triangle. So I have to apply half times base times height. So area of the triangle AOB is half times base times height, which is 49 over 10. That is 4.9 squared unit. And that's the area of this triangle. Moving on to the question number 7. A curve with the equation f of x is equals to x to the power of 4 minus 3x squared plus 4x. Find the equation of the normal at x equals 2. So I have explained you, suppose there is a curve. This is the tangent at this point. So the normal is always perpendicular to the tangent, and these all points are same. That means it's perpendicular at the same point at which we have the tangent, not at any other point. So that means if I want to calculate the gradient of normal, I should know the gradient of tangent. That means the gradient of tangent is, we have to find the derivative. That means the gradient function, we have to find derivative of this, find differentiation of f of x. So f dash x is 4x cubed minus 6x plus 4. So at x equals 2, we have to calculate the gradient. This is the curve, and we have calculated the gradient function. For tangent at this point, the gradient of the tangent, I have to substitute x is equals to 2. So substituting x is equals to 2. So that will give me 32 minus 12 plus 4, which is 24. So the gradient at this point is 24. And normal is always perpendicular to it, and we know that if two lines are perpendicular, their gradients are negative reciprocal of each other. So if the gradient of this tangent is 24, so the gradient of normal will be 1 over 24, negative 1 over 24. So equation of this normal is also y equals mx plus c, since it's a straight line. So this will become y is equals to negative 1 over 24x plus c. The value of x is 2. We have to calculate the value of y, because this point on curve, tangent, normal, they are all at same single point. So I need to substitute x equals 2 in our original equation, that is the equation of a curve. 2 to the power of 4 minus 3 times 2 squared plus 4 times 2. This is 16 minus 12 plus 8. So this is 12. So y is 12 and x is 2. So it's equals to minus 1 over 12 plus c. And finally c is equals to 12 plus 1 over 12, which is 145 over 12. So my final equation will be y is equals to negative 1 over 24x plus 145 over 12. That's the equation of this normal. Moving on to our last question. Again, I'm saying if you have any doubt, just post in comment section. And also if you are looking for one-on-one live online classes, because this the record sessions are pretty much different from one-on-one experience. So when we will interact one-on-one, obviously there will be much more deeper conversation, and it will definitely help you. You will get to know the instant your doubts and everything. And the classes are both the group classes and one-on-one live online classes, and these classes are starting at just £8 per hour, which is very affordable. Okay, moving on to our last question. Question 8 says a curve f of x is equals to x squared minus 4x plus 3 has a tangent gx at 4x minus 13. So they say this is a curve. This is actually a quadratic, a parabola, let's say like this, and it has a tangent like this. Equation is 4x minus 13, whereas equation of this is x squared minus 4x plus 3, and they are meeting at point P. A normal at point P intersect this curve at Q. So that means this is the normal, and this normal cuts, this is perpendicular to this tangent, but obviously it cuts this curve at another point as well. So we have to calculate this point Q. So obviously we have to calculate the equation of this normal. So equation of this normal is very easy. From here, the equation of tangent is y is equals to 4x minus 13, and we know that if two lines are perpendicular, they have the negative reciprocal as their gradients. So gradient of this normal is minus 1 over 4. Now to find the tangent of this, I should know the intersecting points. So the intersecting points are, let's say, x squared minus 4x plus 3 and is equals to 4x minus 13, because this is simultaneous equation, and in that case we just have to equate them. So that will give me x squared minus 8x plus 16 is equals to 0. That means x minus 4 whole squared. So the point is 4. This point is 4, and the point is 4, then the value of y will be y is equals to 4x minus 13. That will give me 3. So 4 comma 3 is the point here. We have just calculated the simultaneous equation simply of the tangent and the curve, and we got to know that the common intersecting point is 4 comma 3. Now the equation of tangent is, the normal is very easy, because we know the gradient as well as the point lying on it. So that will give me y is equals to mx plus c. M is, we have calculated as negative 1 over 4x plus c. So y is 3 whereas x is 4. So C is 4. Finally, we got the equation of this normal as y is equals to negative x over 4 plus 4. That's the equation of the normal. Now we just need to find the intersecting points of this curve and this line. Again, we have to solve the simultaneous equation, which is, let we equate x squared minus 4x plus 3 is equals to minus x over 4 plus 4. Bring it here. So x squared minus 4x plus x over 4 plus 3 minus 4 equals 0. X squared minus 15x over 4 minus 1 equals 0. This is our quadratic equation. Multiply all the sides by 4. So 4x squared minus 15x minus 4 is equals to 0. So the product is negative 16 and sum is negative 15. That means two numbers are negative 16 and plus 1. So that will become 4x squared minus 16x plus x minus 4. 4x taking out as common, x minus 4 plus 1, x minus 4. Final factors are 4x, I'm writing here, I'm running out of the space. So 4x plus 1 times x minus 4. So I get to know the two values of x. One is 4 and another is negative 1 over 4. We already know the P point where the coordinates of x is 4. That means obviously the Q has negative 1 by 4 as its coordinate for x, and for y just equate it on in the equation of a normal, which we have calculated as y is equals to negative x over 4 plus 4. That means this was the equation. We know the normal equation. If it's a bit messy, you can just repeat this video. It's very easy. This concept is very easy. I'm just repeating the basic concept. So basically, the equation of a tangent and the curve is given. So we have calculated their intersecting point, which is this one. We have normal at this point, and obviously this normal is intersecting with another point on this curve as well. So we have to find that another point, and for that the equation of normal is important, and that we have calculated. And once we have the equation of a normal, we can use the simultaneous equation to solve the intersecting points. So we have already calculated the value of x. So now I'm just finding the value of y, which I'm substituting in the equation of the normal. So that will give me y is equals to plus 1 over 16 plus 4, which is y is equals to 65 over 16. So the 2 points or the coordinates of Q is negative 1 over 4 and 65 over 16. So these were the questions on normal tangent. See, these sheets also have some basic questions. We do have the harder questions as well. We do have the mock papers as well. And they are very, very, very affordable. And if you will enroll for live classes, you can access them for free as well. So to access the free worksheets, you just have to visit our website, which is edexcel.com. And if you want to purchase the sheets, purchase the mock papers, or if you want to enroll for live online classes, not only for A-levels, but for GCSEs, for any class from A1 to A-levels, all you need to do is just email us at edexcel@gmail.com and we'll coordinate accordingly. We have the most experienced tutors. They'll definitely help you, and we're very happy to share all the past results. So that's it for today, guys. Everyone, take care. Bye.